All right, here's your quick review over Unit 4. Unit 4 was when we first learned about linear functions, okay? We started with slope, and remember that slope is the same as rate of change, and it's the same as m. Those all mean the same things, okay? So remember that we talked about how slope is equal to the rise over the run, and then we also learned the slope formula, which is y2 minus y1 over x2 minus x1, and that is on your formula chart. So let's find the slope for each one of these representations. So the first one I gave you was just some points. When you have points, you're just going to want to use that slope formula. So I'm going to label my points and then plug them in. So 7 minus a negative 9 over negative 2 minus 3. Remember that that's going to give you a positive. So really that's going to be 7 plus 9. And there's my slope, negative 16/5. If I could have simplified, cool, but I can't, so that's what it is. Okay, when you have a table, this is when you want to do the same exact process, but some people honestly just look to see how the table is changing. So for example, my y values here subtracted by 2, my x values here added by 4, so I put the y on top because it's rise over run, so negative 2/4, which would simplify to negative 1/2. Okay, on a graph, this is when we usually focus on rise over run. You want to find two perfect points. So I've got a perfect point here on my y-intercept, and then I would say maybe this is another perfect point. Okay, so then I want to rise, count that. Some people would say, oh, rise 1 and run 1, 2, 3, 4, 5, 6, 7, 8. However, not necessarily true. You have to look at your scale. I know that each box on here is counting by 2s. So this is really a rise of 2. Okay, my run, I'm going to look down here at my scale and see, oh, every box really is just 1. So that's a run of 1, 2, 3, 4, 5, 6, 7, 8. So rise over run, 2 over 8, which would really be 1/4. Okay, we also talked about slope, the meaning of the slope. Remember that you want to remember that it's y per x. So looking at this graph over here, my y variable is the water level, the feet. So feet per, my x is the number of days, so feet per day. Okay, so the meaning of this slope would be that the water level of the river is going up 1 foot per 4 days, or 1/4 of a foot per day. Either way, those mean the same thing. Okay, another thing we talked about in Unit 4 was intercepts. We've talked about this a lot since then. X-intercepts are the ones that are on the x-axis, y-intercepts are on the y-axis. The coordinates are always going to look the same. Y-intercepts start with the 0, while x-intercepts end with the 0. Remember, this was really important for when we talked about roots or zeros. Okay, they end with the 0. Okay, then we talked about how to put all this together. So when you want to write an equation of a linear function, you have to put the slope next to the x, they're being multiplied, and then you want to add on the y-intercept. Remember that we don't care about the x-intercept. We just kind of let that go. It's not a part of the equation. Okay? We also talked about having Hoy and Buck's equations. Remember that H stands for horizontal, when you have horizontal lines, okay? Remember that the horizon line is horizontal. The O here reminds you that the slope is 0, okay? The Y reminds you how to write the equation. It's just Y is whatever the number is. So for this graph right here, my equation would be Y equals -4, and my slope is 0. Okay, here's another one. Vux, our other type here, the V stands for vertical. Your vertical lines up and down. The U reminds me that the slope is undefined. And then the X reminds you how to write the equations. X equals a number. Think about your line project and how often you had to write in X equals a number for vertical lines. So again, this would be an example of a Vux because it's a vertical line. So my equation would be X equals 3. And my slope is undefined. Okay, then we spent some time graphing. I'm actually going to graph inequalities because you do it the same way as you would an equation, but inequalities is another thing that we kind of struggled with, so I'm going to use that to teach you both. So the first one I see here is y is greater than 5x minus 4. Well, I know that my y-intercept is -4, so I'm going to start with that. Make this a little bit bigger and a little brighter. Okay, so I'm going to start with -4. Then my slope is 5. So I need to go up 5 and over 1 and draw a new point. Then up 5 and over 1. Then I can connect those. Now, with an inequality, you have to be careful. If it's just an equation, you just connect and move on. But since it's an equality, and it's not equal to, I want to draw a dotted line. Okay, so these two are going to make dotted lines. Now I have to shade. It says y is greater. Y is greater. So that means that I want to go up. From all my points, I want to go up. Let me get, oh, that's not the same. So I want to go up, up, up from this line. Okay, so I'm shading all of this part of the graph. Some of y'all look at that and you say, oh, but that's to the left. It's also up from all my points. Okay, you'll notice that the top of my y-axis is shaded. That means I definitely had to go up. Okay, so let's do the other one. What's different about this other one is that it's not solved for y equals mx plus b. So I need to do some rearranging. So I'm going to subtract my x over. And then I'm going to divide both sides by 2. I'm not going to switch the sign because I'm dividing by a positive. So I've got negative 1/2 x plus 2. Okay, so there's an equation that I can graph, or an inequality. I couldn't have graphed it before because it didn't say y equals mx plus b. So now I can start with my y-intercept of 2. My slope is negative 1/2. So this time I want to make sure my line has a negative slope. So I'm going to go up 1, but I'm going to go to the left 2. I could also go down 1 to the right 2. Either way, it's going to make the same type of points. Now, this one says less than or equal to, so I can have a solid line on this one. Okay? This one also says y is less than or equal to. So in this case, I want to go down from all my points. Okay? Down from the points. So I'm going to be shading down the graph. Okay? Now again, you use that same process for graphing an inequality. You just don't shade. Okay? So less than or equal to, greater than or equal to, you have a solid line. Less than or greater than, you just have a dotted line.